Okay, here's where we left off. We're talking about same side exterior. Okay, all you got to do is find exteriors. And when we say that they're the same side, that means the same side of, excuse me, that means the same side of the transversal. Okay, so here's the transversal. So like A would be same side same side exterior with what other letter besides A? A and G would be same side exteriors. All right, and same side interiors would be like C and what? And E. Same side interiors. Now, are those equal to each other? No, those are, what's it called? Supplementary. Supplementary is the key one. Those add up to 180. I guess, I don't know how you're going to remember supplementary versus complementary, but those are the two big ones you got to know the difference between. Supplementaries add up to 180. Complementaries make 90. Here's a dumb way you can remember it. Supplements are like vitamins and stuff. The weightlifting guys take supplements, you know, and it can like turn their life around 180 degrees. Okay, it's kind of lame, but then there's complementary. If somebody gives you a compliment, you kind of like sit up a little straighter, and you know what happens to your body when you do that? When you sit up straight, you make a 90-degree angle. There you go. Okay, so that's just two dumb ways you can remember them. But if I ask for supplementary and you find things that add up to 90, you will be getting it wrong. Supplementary to 180. Complementary, they add up to 90. All right, moving on. I've got a whole bunch of slides that we don't need because we flew through them really fast, and I don't think you needed those because we've seen these many times. Those are vertical angles. Vertical angles are equal to each other. So that means that x plus 6 has to equal 105. Does that sound like an equation to you? And then you could solve the equation. And x would be what? 99. That's all there is to it. So that's mixing a little bit of algebra with a little bit of geometry. It's like a hybrid. It's like a Frankenstein. The body of the one and the head of the other. All right. How about this one? We know that those are not equal, but what do we know about those two angles? Add up to 180. So therefore, you could say x plus 80 plus, and distribute that out, and what would you say? 2s plus 12 has to be equal to 180. Okay, so you could set up that equation. X plus 80 plus 2x plus 12 has to equal 180. And you could solve for x then, couldn't you? All right. Next up, solve for x. I'd like you to do this one on scratch paper right now. Or on your notes. Either way, it's fine. Hopefully you said that. And then you said this. And then you got rid of the smaller x. And then you got rid of the 20. And then you divided by 3. 50. That's what I said. Sorry. So 50 over 3. Raise your hand if you had 50 over 3. Okay, good. If you aren't quite there yet, that's hopefully where you'll get. All right. On to areas of shapes. That very first one, a lot of people get wrong because they just go fast and go, oh, 5 times 8 is 40 areas, 40 square whatevers, square units. What's the right answer? 20, because you got to go base times height and then what? Divide by 2. Okay, this one is pi r squared. So you could give the answer, as long as you don't have to multiply by the actual decimal, you could give the answer very accurately by saying what? 49 pi. Very good. Because it's pi r squared would be 49. 49 times pi. Okay, next one is 5 times 4 gives you an answer of 20 square units. True or false? True. Next one, 8 times 4, 32 square units. True or false? True. The next one, think this through this way. Would you agree that 8 times 4 would be an answer that would be too big? Yeah, because 8 times 4 would be 32, and it would be like this. That would be the answer for this whole thing. That'd be too much. Would you agree that 6 times 4 would be too small? Then Can you imagine that maybe if we don't use 8 because it's too big, or 6 because it's too small, and we use 7, it would be just right. 7 times 4 is 28. Raise your hand if you think the answer is 28. You're right. Because all you have to do is average these two, and it makes sense to me anyway. If the one's too big and the other's too small, we average them. And it happens to work out really nice because 6 and 8 I add up to 14, divided by 2 is 7. Sometimes it'll be a decimal, but anyway, average these two times by that one. All right. So then if you know all those formulas, you should be able to move on to this. What I've done in blue there is pi r squared. Okay, r in this case is x plus 1. And r squared then is x plus 1 times x plus 1, which makes x squared plus 2x plus 1. And then you have to throw in the pi. So your final answer is right here. That's how your answers are going to look today. That is a Frankenstein mixture of a little bit of algebra with a little bit of geometry. Okay. Let's say you were going to do this one right here. You just do base times height, right? Should be able to do that in your head. What's the answer? 4x cubed. Very good. So what if I don't know what x is? I know the answer is 4x cubed. Okay, this one. Base times height. In your head, do you have 4x squared to start with? Plus what? 12x. You got it. All right, on to the next one. This was too small. That's too big. So what should we use? 7x times what? 4x minus 1? 4x minus 4. All right, good. And you'd have it. That's all there is to it. So if you do areas that just have variables in them, then you'll have variables in your answer. All right. So if I told you that the pyramids were designed by people who knew the golden ratio, would you believe me? It's true. They're in the pyramids too. The pyramids have the golden ratio of 1.618 in them. So all the biggies out there. So if all the biggies in the past knew that ratio, maybe, and since you personally have that ratio on your body all over the place, maybe that'd be a good number to memorize. Okay, and it's given a letter in math. They call it phi, like phi, phi, fo, fum. Okay, it's phi, and it's sort of like one of the letters that you also know that goes for the circle. You know that one? What's that one? It's a Greek letter also. Pi. That's, if you don't just make up those letters are Greek letters, and that's pi. Okay, what's phi? It's a phi is a Greek letter, yes. So, all right. That's all we have for you.